it's a great pleasure to be here tonight and participating to this webinar. So I will give you a talk, which I will give you a short overview basically on how artificial intelligence is changing the Swiss Federal Railways, so meaning the railway industry. And as I'm working at this SBB Center of Competence Drones, I will focus actually on drone data and AI. So I'll shortly present you the Center of Competence Drones and what we are doing, and then I will switch to the applications with AI. So this would be my talk. So basically, the Swiss Federal Railways (SBB) has one of the most heavily used railway networks in the world. We have about 10,000 trains transporting above 1 million passengers per day, and we have 6,000 bridges, 800 tunnels, 25,000 retaining walls, and some more infrastructures. And basically, we have two different networks. We have one which is a railway, but we have also energy network, so high power lines, which brings the alimentation to the trains. And we are 4 people working at the Center of Competence Drones, with 1 data scientist and 2 project managers, engineers. And our main task is basically to develop, to help our different departments, colleagues to develop their use case with drones and to define some standards, not only for regulations, but also for processing, analyzing, and so on. So we are also connecting to different companies like Pictera that we saw before, and we are have good contacts in Switzerland, but also all over the world. So we started actually 2-3 years ago with some visual inspections using drones, but then we moved with some automated analysis, so using AI, inspecting bridges or detecting plants. And the plan is that we move then in the long term with autonomous systems, where we have also autonomous drones, and that we can press on the button, the drones capture data, and we can move forward then with some further analysis and analytics. So this is our toolchain. So we cover the entire toolchain: flight planning, data acquisition, data processing, analysis, and decision making. What is interesting is that AI is actually covering so not only the post-processing, but also the data acquisition, so meaning the drones that are flying autonomously, but also during the flights, detecting objects and so on. And we have a long list of applications. I will not go through all this list, but it's just to show that we have some ideas that we bring in a proof of concept. And then once we did the proof of concept and it's validated, we call it then a rollout ready, meaning that we can roll out actually these tests that we did to the entire network of SBB. Actually, when I did this list, I wanted to highlight a bit which of these topics are actually using AI, but then I realized at some point that almost all of them were using AI. So basically, yes, we use AI on a lot of different topics, and I'll show in this presentation some of them. So the technology that we use, I spoke about drones, but we don't only use drones, we also use satellites, imagery, and we combine them also with terrestrial systems, so cameras and also LiDAR and so on. So let's move now to the second part, which is actually showing some of these application examples based on AI. So basically, the first one that I would like to show you is infrastructure documentation. So we have all our infrastructure, which is measured regularly and stored, so documented in a database. And so we have different objects. We have signals, canal, and we have manholes, and so on. And I would like to show the first examples on precisely on the manholes. So we wanted to try to automatically detect these manholes and to update them in our database. So for this, we used actually some orthophotos, so captured from the drones, but also from helicopters, so that we get more data on the longer track. And we used for the training the detection Pictera that you saw before. And so what we did is we started doing some annotations on the platform and also creating training areas. And we got already some very actually good results with a precision of 96% and a roll call of 80%. But we still wanted to actually remove. We had quite a lot of false positives that we wanted to remove from these detections. So what we did first, we added some training time. So this parameter was introduced before by Roger. Basically, it's adding actually some data, some layers in the neural network, and then we also added some annotations. So we did an active learning, meaning we used the detector that we had, and we then reuse the annotations. So we use actually these detections and annotations so that we could go a bit faster. But adding these annotations actually improved quite well actually the recall, so that we could remove most of these false positives. And at the end, just to have a bit some reliability on the results, we added some accuracy areas to get some more consistent values on the precision error recall. So this is how it looks like on the platform. So we detected basically these manholes that we see here, and we had actually plenty of data, so along different tracks. And yes, so basically we used Pictera for this work. And actually, so we did a comparison at the end with our own database, and actually we found out that we had actually more than half of the manholes that were actually not correctly detected. And what we found out is actually that most of these manholes actually were covered by roofs or were covered by vegetation. So basically, it was not really related to the detector, but to the data itself. And also, we actually had detections that were made outside of our parcel. So we detected some manholes that were actually not in the database. So actually, this is why we also have some not correctly detected, but which actually were correctly detected. Then the next topic that I would like to show you here is the vegetation mapping. So the idea is that we want to create some maps using drones and acquisitions from airborne systems. And we want to use this map for treating actually in an analogy to agriculture. We would like to actually to treat these vegetation using hot water spraying vehicles. So we want to make a variable rate application, and we want to use as a basis these maps that we want to derive with machine learning. So the data that we used here was again some orthophotos, and we used here for the training and the detection Pictera. And so we created some annotations, about 1,000 annotations and also 1,000 training areas. And we did some visual comparisons and visual observations that actually the first results were quite promising for us, so that we could use actually these data sets to spray where we have effectively vegetation. Yes, so actually we also had some issues like on the left, on the example of the left image. So basically here we actually mapped vegetation on the top of a tunnel. So, but this is again not related really to the detection itself. It's really it's related to the data. What was actually also interesting is that we detected some vegetation that had some pretty clear patterns. And actually these patterns, we think that they are related to water, so we could actually even maybe infer water under the tracks thanks to the detection of the vegetation. The last topic that I would like to show you is about bridge inspections. So we are talking here about bridges, but we have some further engineering structures. So we have tunnels, bridges, I said, and what I would like to show you here for the bridge inspection is actually the automatic damage detection on concrete bridges. So what we did is we worked together with two different companies, CSEM in Switzerland and Easy Inspect, a Danish company. And CSM used basically a faster RCNN model, which they trained and used for the detection of the damages. And for these, in this case, we used auto facade. So we generate an auto facade of the bridge, and that we used as an input. And Easy Inspect used single images. So I'll show you here a bit the results. So first of all, about the labeling. So we used the CSAM labeling toolbox. And we created different classes: so corrosion traces, bleaching, vegetation growth, and leaching and water saturation. And yes, and the detection worked actually pretty well. So we were quite happy with the detection. We still had a lot of false positives, but as a first result, we were quite happy and showed that actually it's promising using AI for detecting damages on such infrastructures. For Easy Inspect, so basically we mainly use the platform also for visualization and also consolidating the data set to the 3D model and the detected images. So we use the AI from Easy Inspect directly, and this is actually for the different classes, we have a pretty good F1 scores, especially for cracks and bleaching. And yes, so basically we were quite happy with these actually. We were quite happy with these detections, and we did some visual comparisons. And yes, so this was actually our results. So I'm coming up to the end of the presentation. Thank you very much. So I'm happy to answer any questions.